Yeah, if we could take our seats, please, we'll begin in just a minute or two. Oh, okay, why don't we just set her over off to the side somewhere, or maybe just...
We're actually on time, almost.
That's right.
Okay, if we could take our seats, please, we're ready to start. Before we introduce the crew, a couple of brief announcements. We will take questions for this conference from all media. However, we will give priority to those questioners who do not have private interviews. Also, immediately following the conference, we'll spend about 5 minutes with the photographers. At this time, it's my pleasure to introduce the Apollo 14 crew. From my left, Captain Alan Shepard. In the center, Major Stu Russa. And on the far left, Commander Ed Mitchell. At this point, I'd call on Captain Shepard.
Well, it looks like it's going to be a long day, so I won't start off by saying too much. Just a few general comments about the mission. Speaking for my colleagues and myself, we're happy to be flying. I guess that's obvious. We're happy to be getting in the air again as far as NASA is concerned. Unfortunately, although we, as pilots, consider that Apollo 13 was a successful mission, there's a certain stigma attached to it. And we hope that Apollo 14 will be able to remove that, meaning inferring that the problem of Apollo 13 we feel has been satisfactorily taken care of. It's been analyzed properly, the proper corrections have been made to it. The Apollo 14 landing site, of course, we inherited from our previous crew. It's an exciting landing site. Geologically speaking. It adds, of course, to the scientific observation sites which we already have there in the total gathering process of our lunar missions. We are unique, I expect, in terms of length of quarantine. I'm not sure that that's anything to be proud about, but anyway, that's one of our unique positions, apparently. And beyond that, I guess we're just happy to be back in business again and looking forward to flying. Do you have any questions here?
At this point, we'll throw it open for questions. Dave Ward.
I have a question.
Can you wait for the mic, please, Dave?
Question for Captain Shepard. Captain, of course, everyone has drawn the innumerable tie-ins between your first flight. Everybody remembers Freedom 7, and now you're going to the moon. I would like, if you could, to just, for a brief moment, look back to that day in May of 1961, the 15-minute suborbital flight. Now here you have a flight going to the moon. Draw some similarities for us, if you could, and also what are the big differences in those two flights?
I don't think there's any similarity at all, fortunately. I don't know. What can you say about 12 years of, 10 years of fantastic technical progress? I think it's something of which I've been very proud to be a part of. I'm happy to see that we've made as much progress as we have. I'm unhappy that we haven't made more.
Dick Whitkin.
In the light of the accident on Apollo 13 or the explosions, how do you rate the dangers on this flight?
You want to take that one? He's talking about the command module.
Thanks a lot. Well, I think I would say certainly we have a better spacecraft now. I would say it's without a doubt more safe. Everybody has fixed that immediate problem. And I'm sure everybody's pretty well aware of the third oxygen tank and so forth and so on that would absolutely solve a repeat of the 13 problem. But you certainly don't stop there with an investigation and the same thoroughness with which you attack that specific problem that happened on 13. You look at the rest of the spacecraft. All the other tanks that contain high pressures have been thoroughly examined, and all the other wiring and so forth. And so with each lesson that you've learned, you apply that knowledge and you make the spacecraft safer. So I would say that end result that Apollo 14 has a safer spacecraft.
I think that's a good point. I'm not sure that's been brought out too clearly in the past, that not only were the cryo-O2 tanks in the service modules examined, Dick, but also the total tankage problem in both vehicles have been re-examined.
Tom O'Toole.
Captain Shepard, the overriding goal of this flight seems to be to get to Cone Crater. Can you tell us what restrictions you'll have if you land long? In other words, if you land a little bit long, how close do you have to be to still get to Cone Crater? And if you land too far long to get to Cone Crater, or is there an alternate plan to walk to one of the other craters, like I think it's Sunrise, I think, or Star, something like that? Could you tell us about that?
Yes, our geological exploration plan in the From Morrow area, I think, is pretty similar to that of 13. The total area, as you know, is hopefully some ejected material from Imbrium, which is one of the largest, earliest craters of the moon. Cone was picked because it appears to have excavated the Imbrium ejected material to a greater depth. But I'm not sure that, and neither is anyone else, for example, that Cone is exclusive in its penetration into the depth of this ejected material. Other craters in the area, in other words, could quite possibly provide the same kind of clues. So, as in other flights, we have projected various traverses for landing sites throughout the total landing area. Now, I got a lot of figures about how many miles away we'd switch to this particular landing traverse, if you want those. But generally speaking, we have several different traverses planned for the total area. In miss distances up to several miles and still have good geological coverage.
Question?
Does that answer your question? No, I didn't think it did. You don't look like you're with me.
Tom O'Toole.
Self-clear. What I really wanted to know, I guess, is how much further beyond the landing target, how much in do you have to be to still get to Cone Crater? In other words, if you don't land in where you want to land, but land a little bit long, what's the range down there?
Well, I guess, and here again I'm doing it hypothetically because we haven't forced this kind of an on-the-spot decision, but I would suppose we'd probably go maybe as much as 2 miles beyond. Of course, that would mean a total revision of the particular plan, of that particular plan, if you wanted to get back to Cone. But I don't think it's going to work out that way.
Lee Holly.
Can you say any special things that you might be doing on the trip, like the others have played records and things? I noticed that Johnny Cash has supposedly taped some things for you, or any unusual things. And are you going to have a plaque?
You mean about the music that we're going
Yes. Or what are some of the other things that you might be doing that the other crews have not done?
Oh, I don't know. What are you going to do that other crews have not done?
I'm sorry, I didn't hear all of her question. Is that all of what are we going to do that others
I
haven't
guess
done?
that's the question. What are we going to do that other crews have not done during the long, lonely hours in space?
Yes, yes.
That does pose a problem. Your activities are somewhat restricted.
I plan to cry a lot. That's the obvious answer.
Going to be reading any Bible verses or anything like that?
If you're asking me if I'm going to be reading any Bible verses, the answer is no.
Question? We have any further questions in this conference? Jules Bergman?
Al, have your feelings about the dangers of this business changed since Apollo 13?
No, I don't think that my feelings about the dangers of the flight have changed. We try not to kid ourselves in that respect, and as you know, since the early days of the program, everything has been analyzed as analytically as we can analyze it. The total strength of the technology has been applied to all the problems as we see them. I think this has been done in this particular case, and I think that really the Apollo 13 proved out the validity of that concept. Although the flight was not totally successful, it did in fact return the crew with an awful lot of additional data, return them safely, and since you're talking about danger per se, I'm assuming you mean a safe return. And of course it's awfully hard when you talk about the difference between a success of 4 nines and 5 nines or 3 nines, it's pretty hard to put that in terms that anybody can understand, even including you and me. But I think the same careful approach that we've always tried to have is still with us, and I think that from what Ed and Stu and I have talked about in the past months, we're pretty confident that things are going to work well.
Yeah. Just add a little to that. For a specific example is like we're now carrying a new checklist called the contingency checklist, and this takes into account, in fact, has timelines in it. You know, that if you have something catastrophic that happens at certain periods in lunar orbit, it's pretty well laid out very specifically. Like, say, what happened to the CSM on the backside on one pass. Then the procedures are very specific on what you do, how you get the spacecraft safe, still keep the comm up, and then exactly what you would do from then on to get the 2 vehicles and power profiles and so forth to come back. So, and also in lieu of 13, there's been a lot of study. It's not necessarily in the flight procedures, but they're available on the ground as using the LEM as the lifeboat mode in the ascent stage. And this has been proven in the sims that you have a problem and the mission control have all their procedures all squared away. They immediately go to Plan Baker and put it into action. So both in our in-flight data and in mission control, I think everyone is very organized. And it's not that they weren't before, but for these specific type of catastrophic events.
I'd like to pick up on that just a bit, Jules. With what Al and Stu have said, and couple that with the previous question about 13, I think we all agree we have a more mature spacecraft than we've ever had in the past. And presumably, as you fly, you get more mature spacecraft. And the residual risks go down. Apollo 13, one data point, supposedly it had a 0.999 something success factor associated with it. One data point to the contrary makes you perhaps doubt those numbers, but they still exist. And we're convinced at this point that we do have a more mature, safe spacecraft, and the residual risks of problems are subsequently reduced because of it. But nevertheless, there's still a finite probability that we can always have a problem that we haven't seen before, or even one that we have seen before, but just hardware failure has caused it. But it's pretty small probability.
John Wilford.
Captain Shepard, as the one of the original 7, I guess the last one on active duty, what are your plans after Apollo 14? Do you have any plans to leave the astronaut corps?
Well, let me say, first of all, there's still another one of the 7 on active duty, Deke Slayton, who's still with the Space Administration, and who works very hard to help us train and keep equipment available for us. Secondly, I really haven't looked beyond the mission. I'm concerned exclusively with that at the moment, and have made no decisions about my plans after the flight.
Nick, Chris?
Captain Shepard, you've had some success in the business world. There have been various reports about how much success you've had. Why don't you simply choose to stay in your mansion in River Oaks instead of going to the moon? What's your main, what's kept you going at it this long?
Well, let me say I've had some failures in the business world also. First of all, with respect to your answer about why I want to continue to fly in space, I guess it's because it's about the only business that I know. I've been trained as an aviator for years, really trained as nothing else. It's something in which I enjoy making a contribution. It's something I believe in. And fortunately, I'm healthy enough to be able to be given another chance to go. Lots of things, I guess, all add up to my desire to go into space again.
Lou Alexander?
A question for Stu, Bruce, and Ed Mitchell. You have 15 minutes less flying time and no landings at all in space, no flights at all in space. What portion of the flight are you each looking forward to the most?
Well, I guess I was asked that same question down at the Cape, and you know, you got to take each portion of the flight as it comes, and you can't get to any part of the flight until you've had the liftoff. And so I'd say right now, I'm working the best thing I'll be looking forward to is when that beauty really lifts off, and then you know you're on your way, and maybe get a chance to you will get the chance to do the mission that you have worked and trained so hard for.
For my part of that, I think Stu gave a good answer, which is applicable to me, but in order to have a little different answer, obviously, if everything goes well, I'm more of a passenger than anything else in the first couple of days of the flight, although I do obviously have my duties on the right side of the spacecraft. It's not until we do lunar orbit insertion that I really bring all of the hours of limb training to bear. So obviously I'm looking forward to the time when we crank up the limb for the first time.
Art Hill?
Captain Shepard, what's your current assessment of the morale at the Cape?
Well, I think that the morale at the Cape is decidedly different than it has been in the past months. I think that it's better. I think that's associated almost entirely with the upcoming Apollo 14 mission. I think it's exciting to even those people outside the gate when they roll that big vehicle out there and start fueling it. But I guess the people at the Cape feel like everybody else, that directly associated with the aerospace profession, that we'd like to see more progress than we're projecting over the next few years.
Lee Holly?
Can you comment on the choosing of the astronaut symbol for your insignia for your spacecraft, the pin?
Lee, I don't hear you very well. Can you get closer to the mic?
Can you comment on the design of your emblem, choosing the astronaut pin for the spacecraft?
Yes, we decided a long time ago that Ed was going to name the limb and Stu was going to name the command module, and I was going to designed the insignia, and I guess perhaps some of you know that the pin, which is a star with a classic orbit and a comet's trail, is a pin that the astronauts have adopted for their use for a number of years now. It had not been used before, and it occurred that it might be nice to put it on our Apollo 14 emblem. And do you want to comment about Kitty Hawk?
I guess we might as well, to beat the question, Al has mentioned about the naming and the patch, and so, you know, one of the hardest things so far in this year and a half of training has been to try to decide on a good name for the command service module. And that's quite a job when you get down kicking around names, and so I finally went back to something I'm real familiar with, and that's aviation. And like Al mentioned a minute ago, that's been his whole life and really mine. And so I thought I'd just go back to where it all started, back to Kitty Hawk. And it's just that simple.
As Stu pointed out, we spent quite a bit of time trying to choose names, as Joni and my wife happen to know. We spent quite a few hours considering different combinations of names, and we could just never get together. And on names that we thought were euphonious, meaningful, and had the proper symbolism. The name Antares for the lunar module, obviously a stellar name, and it shows it because the constellation Scorpius is the constellation that Al and I are looking at when we start down to the lunar surface. And Antares is the brightest star in Scorpius and happens to be very close to the z-axis of the spacecraft. In other words, right along our line of sight when we start down to the lunar surface at PDI. And it's as simple as that.
Anybody of you is Scorpio?
Pardon?
Anybody of you is a Scorpio?
I'm not.
By coincidence, I am, but it had nothing. It didn't influence his decision, right?
Right.
Totally independent decision.
In fact, it was so independent that when Ed and I would get hung up on names, Al would offer no help.
Any further? Rhett Turner? Can you wait for the mic, Rhett?
I was really hoping somebody else would ask you this, Al. Some of us have done a little checking historically, looking at the Russian cosmonauts and the American astronauts. You're going to be the oldest guy to have gone. You're 47 now, right? 47?
Whatever it is.
Yeah. Okay. Wax eloquently a little bit about being the old man.
I'm glad
in
somebody
space.
keeps track of it.
Just open up a little bit about any problems you had and/or how you feel about being the granddaddy of space, I guess. I'll withdraw that word. I withdraw that word.
What kind of historical research have you been involved in? Old and tired. I don't know. What can you say about that? I guess it's except that to say maybe you can't necessarily associate old age with lack of activity or the reverse. I don't know. I've tried to figure out good things to say about that because I obviously get asked that a lot of times. And there I am, and unfortunately you guys know it, and there's not much I can really say. I don't have a historical sense associated with my old age. I mean,
Lee Holly? I don't think we're reading you.
just repeating the first question I asked you because I didn't get an answer. Is there gonna be a plaque as before, and are you gonna put a flag on the moon as before?
Do you want to talk about the limb plaque, Tom?
Yes, there is a limb plaque, as on previous missions. It is already, I guess, in the engraving process, probably already at the Cape to be installed. It has the spacecraft name, our names, the date, first standard sort of thing, same as we've had before. And there will be a flag ceremony as in the past. And hopefully we'll have it well on TV for you.
And there'll be a number of, personal items that we carry along as the previous crews have done, and there'll be some music that Stu's going to play when we're gone, and there'll be some music that we're going to play when he's asleep. All those good things.
Any further questions? Could we move to Reed Collins, please?
Can't hear it. We don't hear you.
You got one that works? All right. You've already expressed your satisfaction with the modifications made in the post-13 situation. Not everybody here and in other places seems terribly pleased with the idea of making a vast modification because of basically a procedural goof. And Pete Frank, even Dr. Kraft have expressed some reservations about the extent to which the cryos have been modified and changed. What exactly is your position about that?
Well, I guess it's a matter of terminology here. I think there's been a vast amount of attention applied to the problem. I'm not sure that we're talking about large structural changes to the tank. The tanks themselves, or the shells, the principles, are the same as they have been. Now, there's been a modification to some of the things that go inside the tank, but these, again, provide only artificial energy, heat, measuring the temperature, and these kind of things which are not generic to the operation of the basic tank. The basic tank is the same. An additional tank has been added. But I think here a vast amount of attention has been applied to the hardware. And I don't, it really hasn't been, to use your words again, it hasn't been a vast change to the hardware. The changes to the hardware per se have been minimal.
May I pick up on that a moment, Al, and address it in sort of a philosophic vein? I think as technology progresses, or as we learn more about our spacecraft, and even as we learn more about technology while we're flying the same spacecraft, we sometimes find situations which are suspect. And let me illustrate. Perhaps 2 or 3 flights from now, someone will make a breakthrough in a new area of engineering that might point out everything we've done up to now. We had a very dangerous situation on board that we never realized. Now, obviously we have flown with such a situation if it were to occur. And so at some point you might have to make a decision. Do we change out a particular tank or a particular component because we've learned something new about it? And attendant to that change is always the risk that you're going to do more damage to the spacecraft, thus the risk of incurring a problem may be as great as the risk of changing out something you're already familiar with. And I think this is always a management and an engineering decision that has to be made on the spot. And although I'm speaking in generalities right now, you cannot generalize on what you would do in those situations. It is always a game of probabilities and your best engineering judgment at the time as to what the technology and the current plan for changing out a piece of equipment shows you to be the best decision.
John Lanner?
Talking about engineering details and looking forward to the evolution of the Skylab, do you people see the move into the Skylab of as much of a transition as perhaps moving from Gemini into Apollo, and particularly considering that Skylab is a transitional spacecraft somewhere between the space station and the Apollo program?
Well, what parameter do you want to use to measure it? Do you want to measure it in apples or oranges or inches or yards? Do you want to talk in terms of duration of flight or velocity?
In terms of a new spacecraft, something that hasn't been flown before and which is a new
but you
bird
said,
entirely.
is it a big step? Now, how do you want to measure the step?
As a technological evolution.
Obviously, if you're talking about distance away from the center of the Earth, it's a regression. Now, what kind of parameter do you want to use to measure it by?
Well, let's say a technological evolution and risk factor in a new bird.
Well, I think that as far as the technological evolution is concerned, the Skylab provides information more in the area of physiological responses than it does in terms of hardware. We're talking here about Earth orbital flights, so that we're not extending the performance envelope of the vehicle. We're not going farther out. We're not going faster than we've been before. These are kind of things that we're not doing. The kind of things that we are doing is we're taking a chance to slowly and carefully analyze what happens to a human being when he's in space for long periods of time. We've already proved with the moon landing that he can go long distances and come back fairly successfully, but we haven't really taken a long look at how he can perform, basically, for long periods of time. Secondly, are there things which he can do in the way of experiments beyond those capable of being completely automated, in which a man takes a good part, that he can do in these long flights? So we're talking about extending our sphere of knowledge, our technical capabilities in an entirely different direction. So the advance there, I suppose, is more from the standpoint, as it properly should be, of, okay, now we've done the wild things, let's see what we can do to directly benefit ourselves, the American people, from a standpoint of the space program. It's kind of like, well, maybe it's kind of like going to the South Pole. You say, okay, I've proved I can do it, now why do I want to go back there again? Well, I want to go back there again because I want to establish a weather station and find out what weather is going to influence the continent of Australia. These are the kind of things I think that we see in the transition to the Skylab program. A practical application, say, direct benefits from some of the things that we've learned going to longer distances and higher velocities.
Good, Doctor.
I think since Apollo 13, NASA is the first American agency, government agency, to go metric. All ACI charts are, of course, in meters and kilometers. Will you be the first crew on the moon to talk in meters and kilograms, or will you use the old British system of pounds and feet still?
I'm not going to make any predictions. You'll probably get a little bit of everything.
If you're right in the middle of a change, sometimes you think in one set of units and sometimes the other. We may come out with most anything as far as units are concerned.
It has to be a gradual transition, you know. After you move into a new house, you can't even remember your own telephone number for several weeks.
Tom O'Toole.
The geologists tell us that when you and Commander Mitchell get to the top of Cone Crater, you'll be seeing the oldest rocks that any astronauts have seen on the moon. They also tell us that
As well as the oldest astronaut, huh?
I didn't say that.
Oh, that wasn't the question? Okay.
They also tell us that you'll be seeing many thousands of rocks because it's a very rocky crater. You have about 30 or 40 minutes to gather the rocks you want to pick up and bring home. Could you tell us a little bit about what you'll really be looking for and what kind of rocks you'll choose to bring home?
You want to start off on that one?
Yeah, we're going to look for one that has 4.5 billion years old written across it. I'm sorry, the only way that we're going to be able to find what we're looking for is by sampling techniques. I doubt very seriously that we will be able to judge on the lunar surface what rocks we're picking up. As a matter of fact, I'm not sure we even want to attempt to do that unless it's obvious to us. Field judgments in geology are very subject to error. So we have devised our techniques to give us the highest probability of bringing back what the scientists want and the highest probability of thoroughly sampling the area so that we can collect a little bit of everything that's there. And it'll have to be a post-flight analysis as to how well we did. And obviously we will never know unless we were to go back and sample the area more thoroughly whether we did a good job. But we feel, and the geologists feel, and the other scientists that have helped with the sampling techniques feel that the procedures we will use will give us a maximum chance of picking up everything that's there, including the oldest rocks, the youngest rocks, and the distribution spatially and distribution in age.
This is an old, tired question, but it comes up every flight. I wonder if each one of you could sum up why you feel the great mass of American taxpayers should pay the bill to send you to the moon.
Why us taxpayers should pay the bill? I don't know. It's very difficult to try to put it in a few words, in a summation of why people should spend their tax dollars in the space program, because it's not a simple thing. As I said earlier,